Hey, welcome back. This is Professor Roldan again with Intermediate Algebra, section 14.5, Radical Equations. Okay, so in this section we're going to be solving for x, but we have radical signs in all of our equations. So what do we do about that? That's what we're going to talk about in this section. Remember, this unit is this is chapter 14, part 2, which is only two sections, 14.4 and 14.5. So your test for chapter 14, part 2, okay, is only going to include 14.4, which was basically adding, subtracting, multiplying, and dividing radical expressions, okay, or square root expressions. So this is 14.5. So all you have is two sections for your homework, and let's get started with this section. So before we begin, you need to go ahead and print this out somehow, or have this be able to fill this out digitally, however you are, whatever your preference is. But we're only going to go over some of the main examples in class. Okay, so the key to solving equations involving radicals. All right. So the main thing is squaring both sides, okay? And this is why. When you square a square root, you get the same base. Okay, so another example like this one would be, if you have square root of 3, we can do the 2 on the outside and get a 3 as well. Okay, so the square roots in the square are opposites or inverses, and they just cancel each other out. Okay, so that's going to be the main technique, but we do want to go ahead and write down some steps that you need to follow. Number 1 is always isolate, not the x first, isolate the radical. Okay, which in this section is just going to be square roots. So isolate the square root or the radical. Okay. Once you have that by itself, then you want to clear out that radical. Or the square roots. And we're going to do what we just talked about, which is squaring both sides. That is the inverse operation. Okay, we're going to see that in a second. Once you do that, all your radicals disappear. And so now you just need to solve for x. And once you solve for x, you cannot stop there. This is one of the few sections or topics where you must check your answer. Okay, it's not an option. And the reason is because we have to check for extraneous solutions. And basically what extraneous means is that sometimes you're going to get x's that don't check. When you do your check, it's not going to be true. It's going to be false. Okay? So we're going to see some examples very quickly here. So again, isolate the radical. Then square both sides. Solve for x and check for extraneous solutions, okay? All right. So let's see a very, 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 very basic one. Here, step 1, the radical is already isolated. It's by itself. Oh, so we just need to go to step 2, which is to square both sides. And so that's going to give us x equals 25. Okay? That's it. One step and we're done. However, we need to check for extraneous solutions. So, what we're checking is this, if you plug in that x, do we get 5? Well, square root of 25 is 5. So yes, we do. This is true. So once that we know that it's true, then we can box it and say, okay, this is our solution. Okay, but if you don't check it, you cannot box it as your final answer. All right, let's try this one over here. We're gonna the x is already, the radical is already isolated, so we're gonna square both sides, and that's gonna give us x equals 9. Again, don't box until we check it. So the square root of our solution, does it equal -3? And of course it does not, because we get +3 on the left. So this is a false statement. Okay, so once you get a false statement after you do your check, that means we do not box this. Okay, this is not a solution. There is no solution. Okay? So you must check it. If you get a false statement, that means there's no solution. Or at least that solution is not true. Okay? Alright, let's take a look at some more examples here. So the first question you ask yourself, is the radical isolated? Yes, it's isolated, so we can go ahead and get started by squaring both sides. Okay, so that's going to give us x plus 2 on the left, because the radical disappears, and then 25 on the right, and we simply isolate or solve for x. So we need to check our solution before we make it our final answer. So the question is, if we plug in the x right here, do we get 5? And it looks like we do. This is a true statement. So therefore we can go ahead and box our answer for being final. Okay, so this one here, this is not isolated. So here we do need to do step 1, which is to isolate the radical, okay? So that means we need to get this 5 to the other side. Once we do that, our radical is isolated, and once we do that, then we can square both sides. So square those two, the radical disappears, and we get 16. Then step 3 is to solve for x. So we're going to add 7 to both sides. And we're going to get 23. Now before you make this your final answer, we do need to check. So the question is, do we get 9 if we plug in a 23 right here? And that's going to be 16. And that's going to be 4. And 9 equals 9. So this is true. And if it's true, then we go ahead and box our answer. Okay, so we've been using 4 steps to solve for x for radical equations. Now it's your turn to try some of these. Alright, so let's go ahead and pause the video. Try the steps we just did together and see what you get. And then check your answer after you pause the video. Okay, so hopefully you have y equals 446. And then this one, square both sides, add 5 to both sides, get 446, plug it in to check. 446 minus 5 is 441, take the square root, get 21. Alright, I would like to go over B in class. Okay, so you're welcome to get started if you want, but we will do that in class. So let's go ahead and go to the next page. Okay, so is the radical isolated? Well, definitely not. We got to take care of this 21 and this 3 in order to isolate that radical. So we're going to start with a 21. Then we can divide both sides by 3, or negative 3. Okay, so this is 2 steps to isolate the radical. Now that the radical is isolated, or in other words, all by itself, now we can raise both sides to the second power. Eliminating the radical, we get 49, and solving for n. So we get n equals 7, but we need to check it to make sure it works. So do we get 0 from this? Well, 3 times the square root of 49. 3 times 7, 21 minus 21, which is 0. Okay, and if it's true, that means this answer is true. Okay. So let's go ahead, you can try this one on your own. I do like to review this one in class. Okay. And now we have a little mini lesson on factoring, except we have equal signs. So let's take a look. Okay, so a little factoring review here. So first of all, we have a trinomial and we want to factor as usual. The only difference is we have an equal sign with a 0. Okay, and I'll show you what to do in a minute. But basically, you want to do what times what is x squared? It's x times x. And then negative 24 could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. Any one of those combinations, but we need a negative 2 through subtraction, okay? So subtraction, we're going to get, or the difference between these two factors, we need a difference of 2, which is right there. Okay, how do we get this negative 2? We need a negative on the 6. So, put a negative 6 here, positive 4 there. So once you factor, actually, there's two things here that are multiplying to get 0. That means one of those factors has to be 0. So we're going to separate this one and separate that one to test to see what x would make this 0 and what x would make this expression or equation 0. And the answer is kind of obvious. It's the opposite of what you see there. Negative 4. And 6. Okay. So that would be the solutions to a quadratic function or equation. Okay. So why don't you try this one? And pause the video to see if you can do it on your own. And we'll check your answer in a minute. Okay, so you should have gotten x equals 4 and x equals 9. Okay, how did I get that? I factored the 36 is positive. So those are the factors. Which one adds up to a 13? It's 4 plus 9. Negative 4 and negative 9. I'll give you negative 13. Separate these two into zeros and solve for x. Okay. So why are we doing this? Is because we need to do this eventually for radical equations. So let's take a look at C. C, we want to go ahead and get, make it look like this. A, B, C on the same side and 0 on the other side. So what we can do is actually add 2x to this side and subtract 35 at the same time if you want. So there's my 0. X squared plus 2x minus 35. Then we can factor this out. Okay. So think about it. What two numbers multiply the negative 35? That means one of these are negative. We're subtracting, and we get 2. Well, positive 7 and minus 5. Okay. All right. So let's save this one for class. As our little mini review of factoring. Okay. And so now let's go to the other page. All right, so this brings us to our last page here. And there are two questions on your homework that are like these. And so this is what happens when you square one of the sides. Trying to get rid of the radical, you actually create a quadratic. Okay, so if we took a look at number 3, or example 3, the radical is already isolated, so we just need to square both sides. So that's going to create no radical over here, but it creates this x squared on the right. So now we have a quadratic function that we need to solve. So we need to get all the terms on one side. So we're going to take this term and move it over, take this term, move it over. So I'm going to go ahead and put it right here and right there. And now we need to factor this, okay? So each one of these subtracts to get the 8, and I see it right there. 10 minus 8. Oh, 10 minus 2. All right, so 10 minus 2. So it's going to be x minus 2, x plus 10. Separate each of these to see which one can equal 0. Okay, again, don't get excited and box both of these answers. We need to check these to see which ones, if they're both true, if they're both false, maybe one of them's false. So let's take a look. So we're going to check right here. So we can just check both of these here. So let's see. Whoops, that's too big. So 20 minus 8 times 2, is that going to equal a 2? Okay, so let's see. 20 minus 16. 20 minus 16 is 4. Square root of 4 is 2. Yes, this is true. Okay, so that means x equals 2 is true. That is a solution. And then if we check the other one, we're going to see if this equals negative 10. So 20 plus 80, that's 100. And we do not get a negative 10 from that. We get a positive 10. So this is false. And if it's false, that means this is not a solution. That means our only solution would be x equals 2. Okay. So as you can see, it's a lot of work. Go ahead and try B on your own. And we'll see how you do in a few minutes. Okay, just to give you a little head start, you should have gotten this much. Square both sides because the radical is isolated. And that creates this quadratic over here on the right side, which we have to repeat and then FOIL. Okay, you put those together. So again, keep going. Okay, so we got a lot of work here for B. And as you can see here, after we FOIL, we put these two together to make negative 10. Move both of these terms to the right by subtracting. So subtract, subtract, you get 0. So negative 10 and negative 1 make negative 11. 25 minus 7 is 18. Break down to 18. We're trying to get 11. Okay. And so we got our negative 2 and negative 9. X equals 2, x equals 9. And we check both of those. And 2 plus 7 is 9. That does not equal negative 3. So this is false. This is not a solution. And then here, we got 9 plus 7 is 16, which is 4. 9 minus 5 is 4, so 4 equals 4. Therefore, our solution is 9. Okay. So this is example 3, or page 3. And I want you to go ahead and try A. Actually, we'll do these two in class. So you can try them out now if you want. And of course, some of these reviews will be for your turn-in. So this is it for 14.5. And again, this is just a good head start as we look into this more on Wednesday. But I do hope you watch the video and get ready for Wednesday, because the test will be on Friday over 2 sections, 14.4, 14.5, and you will have a review to do for your own benefit for the test. All right, well, see you in class, and see you in the next video. Bye.